Okay, before we start the lesson here, I just want to encourage you again. You can stop and pause the video if you need to make sure you get the notes. Also, if you don't understand something, feel free to rewind and read it again. And if you still have questions, make sure you ask me in person so that we make sure that you understand. Okay, for this first one here, it says, what is the sum of the expression? Well, the sum of an expression is the answer you get when you add numbers together. So if we take 12 plus 23 plus 8 plus 7, we're going to get an answer of 50. Now, how did we find the sum? Well, one thing we can do is we can just add from left to right. We can do 12 plus 23 plus 8 plus 7, and we'll get 50. 12 plus 23 is 35. 35 plus 8 is 43, and 43 plus 7 is 50. Okay? So you can add from left to right. Now another thing we could do, instead of adding from left to right, is we could make this a little easier and maybe rearrange the numbers a little bit and do the 12 plus 8, and I'm going to put that in parentheses, because again, I know 12 plus 8 is going to be 20. And then I could add the 23 and the 7 together, because that's easy to add together, because that's going to be 30. And I know 20 plus 30 is going to give me 50. So what we're doing there is we're using some number properties. And again, we're going to talk about them some more as we go on. But those number properties make some calculations easier for us. Looking at this slide here, it's just telling you arithmetic includes the 4 operations of addition, subtraction, multiplication, and division. And these operations will follow certain properties that are always true. Okay? And because they're always true, we're able to use them whenever we want to. So the first example just goes through our previous slide. So if you need to take time and just kind of look at that again to further understand it, you can go ahead and do that. Looking at this here, again, it's just telling you you can change the order and you can group numbers that add easily to make addition easier, okay, because of number properties. The thing I want to highlight here is the definition of an equation. So an equation is a mathematical sentence that includes an equal sign to compare two expressions. So again, the important thing about an equation is it has the equal sign. That's what makes an equation an equation. Now those equations can be true or they can be false. So looking at the next example here, we have this equation, 4 plus 3 equals 2 plus 5. And as you can see, it says it's a true statement, because if I take 4 plus 3, I'm going to get 7. If I take 2 plus 5, I also get 7. So there's an example of a true equation. On the bottom, starting right here, okay, this one is an example of a false equation. 4 plus 3 equals 7 plus 3. Because if you take 4 plus 3, you're going to get 7. If you take 7 plus 3, you're going to get 10. Well, 7 does not equal 10, so that's a false equation. So as you can see, to show that 7 is not equal to 10, they put a slash through the equal sign. When there's a slash through the equal sign, that means that it's not equal. Okay, so we're going to work with equations that lead us to these number properties. All right, so looking at number 1 here real quick, just looking at A, 8 plus 0 equals 8. Well, you know that's true. That's something you've done for a long time. If you look at B, it says 8 plus 0 is 80. Well, that's false, because we already know that 8 plus 0 is 8. not 80. So that gives us a false statement. Okay, so as you can see, I've gone through and labeled them as true and false. And then number 2, it just asks you, when you add 0 to a number, what is the result? And when you add 0 to a number, you're just going to get the number itself back. Okay, like 8 plus 0 equals 8. 24 plus 0 just equals 24. Okay, and then to represent that property for any number, we just say a plus 0 equals a. A could be any number. If I add 0 to any number, I'm just going to get that number back. All right, the next one we're going to look at here involves multiplication. So if we look at A, 5 times 1 equals 5. Again, you've known that for a long time, that's true. If I look at B, 5 times 1 equals 50, well, we know that's false because we already know that 5 times 1 is 5. So again, I've gone ahead, I've labeled the rest of them as true or false. And then going down to number 4, it says when you multiply a number by 1, what is the result? Well, just like adding 0 gives us the number itself back, so does multiplying by 1. When we multiply by 1, we just get the number itself back. So a way to represent this for any number is to say a times 1 is going to equal a. Okay, just like in the examples of number 3, 5 times 1 equals 5. If I multiply 5 by 1, it's just going to stay 5. If I multiply 25 by 1, it's just going to stay 25. All right, so that, you've seen an example of that with addition, adding 0. Now you've seen an example with multiplication, which is multiplying by 1. They both give you the same number back. All right, now let's take a look at these examples here. So if I look at A, I've got 5 plus 1 equals 1 plus 5. Well, I know that 5 plus 1 is 6, and if I do 1 plus 5, that's also 6. So that's a true statement. Same is going to be for number B. 9 plus 3 is going to equal 12. 3 plus 9 is going to equal 12. Now, if you look at C, they changed from addition to subtraction. So now, if you notice, if I take 5 minus 1, I would get positive 4. If I switch them around and do 1 minus 5, I get negative 4. Well, those are not the same number, so that is false. That's 4 does not equal negative 4. So same for D, 9 minus 3, that would be positive 6. 3 minus 9 would be negative 6. Again, not true. That would give you a false statement. So if we look at number 6, when you add two numbers together, what happens to the sum if you change the order of the numbers? Well, the sum does not change. It doesn't matter what order you add numbers in. You will always get the same answer. Number 7 says when you subtract one number from another number, what happens to the difference if you change the order of the numbers? Well, if you change the order of the numbers when you subtract, the difference changes. The order that you subtract matters. Okay? Now, the only time this isn't true is if the numbers are the same. So if you took 7 minus 7, for example, you would get 0. Well, if you flip those 7s around, you're still going to do 7 minus 7, and you're still going to equal 0. So that's the only time that does not work for subtraction. All right, looking at this slide, now instead of addition and subtraction, we're looking at multiplication and division. So again, if I look at A, 5 times 1 equals 1 times 5. Well, if I do 5 times 1, I'm going to get 5. If I do 1 times 5, I'm still going to get 5. Okay, same is true for B. 9 times 3 is going to be 27. 3 times 9 is going to be 27. So that one is true. Now, if we do division here, like in letter C, if I do 5 divided by 1, I'm going to get 5. If I do 1 divided by 5, that ends up being 1/5, or if you typed in 1 divided by 5 in your calculator, you would get a decimal, you would get 0.2. So again, that's not true, that's false. We put a slash through that equal sign. So looking at number 9, when you multiply two numbers together, what happens to the product if you change the order of the numbers? Well, the product doesn't change. It does not matter what order you multiply numbers in, you will still get the same answer. For number 10, when you divide one number by another, what happens to the quotient if you change the order of the numbers? Well, the quotient is going to change. If you change the order in which you divide two numbers, you will get a different answer. And again, the only time this isn't true is if the two numbers are the same. So the only time I can switch the order of dividing two numbers and get the same answer is if they're both the same. So for an example, like 7 divided by 7 would be 1. Well, if I switch those 7s around, it's still going to be 7 divided by 7, which is still going to be 1. Our next slide here talks about grouping addition and multiplication. So if you look at A, you'll notice on the left side they grouped the 4 plus 3 together, and on the right side they grouped the 3 plus 2 together. So the numbers are in the same order, they're just changing the grouping. So if you look at the example, if we do 4 plus 3 first, we're going to get 7. So on the left side we're going to end up with 7 plus 2. On the right side, we have to do the 3 plus 2 first, and we get 5. So we end up with 4 plus 5. Well, 7 plus 2 is 9, and so is 4 plus 5. That's also 9. So again, that gives us a true statement. If you look at number 12, when you add more than two numbers together, what happens to the sum if you group the numbers differently using parentheses? Well, the sum does not change. You still get the same answer no matter which pair of numbers you decide to add first. This goes back to our first example that we did, where we combined, where we added the 12 plus 8 to get 20 and the 23 plus 7 to get 30. We used this idea, we grouped them differently. And then if you look at C, same thing with multiplication. So on the left, they grouped the 4 times 3 together. On the right, they grouped the 3 times 2 together. And as you can see, it still results in an answer of 24 for both sides. So looking at number 13, when you multiply more than two numbers together, what happens to the product? If you group the numbers differently using parentheses, nothing happens. The product stays the same. The product does not change. So after going through all those examples, it brings us to the number properties. So the examples in number 1 were examples of the identity property of addition. And that just says you can add 0 to any number and you're just going to get that same number. Moving over to the right side, under properties of multiplication, the identity property of multiplication, we did examples of that in number 3. And again, that just says any number times 1, you're going to get that same number. The next property of addition, which we looked at in number 5, is called the commutative property of addition. The commutative property of addition just states that you can add two numbers. It doesn't matter what order you add those two numbers in, you're going to get the same answer. Same under multiplication, we have the commutative property of multiplication. Those examples were in number 8. And again, it does not matter what order you add two numbers, you're going to get the same answer no matter what order you add those two numbers. The next one under addition is the associative property of addition, and we looked at that in number 11 in letters A, B, and E. Again, what that says is you can, if it's all addition, you can group them. No matter how you want to group them, you're going to get the same answer. So whatever two numbers you decide to add first, You know, whatever order you want to do it in, it's going to work out the same. Same with associative property of multiplication. I can, if we're going to multiply more than two numbers together, again, as long as it's all multiplication, I can group those numbers however I want. I'm going to get the same answer no matter what. And then the last one there, we didn't have examples about it, but it's a very easy one, and that's the zero property of multiplication. And that one just says, anytime you multiply by 0, you're going to get 0 for an answer. Does not matter what number it is, how small the number is, or how big the number is. When you multiply by 0, you're going to get 0 for an answer. Now to finish up here, number 15 is just talking about addition and addition and multiplication are commutative, and subtraction and division are not commutative. And if you look at the examples, the reason is with addition and multiplication, the order does not matter. With subtraction and division, the order matters. 16 is talking about 0 being called the additive identity. And the reason for this is the number that you add 0 to maintains its identity. Okay, it stays the same. And that's the same for number 17. 1 is often called the multiplicative identity. And again, because when you multiply any number by 1, the number stays the same. It maintains its identity. And then to finish up here, how do the number properties differ from other equations? The number properties are always true. Other equations might be sometimes true or never true, but the number properties are always true. Okay, make sure you turn your note sheet in when you finish the homework online.